Good morning, welcome to WASSCE Academic's online tutorial. Thanks for watching our videos online. Please, if you have not yet subscribed to this YouTube channel, please do well to press the subscribe button and the notification button now in order to see all of our subsequent videos online. Also help us to make this channel know in order to serve you better and to also to help others to see these videos. Thank you and God bless you. Now today we are considering what? Qualitative analysis. Qualitative analysis. We are talking about qualitative analysis. We are talking about what? The test for cations and anions. Qualitative analysis is all about the test for cations, anions, and the gas presence in a particular sample. So now the question goes to say E is a mixture of two inorganic salts. E is a mixture of two inorganic salts. The following tests were carried out on E. Complete the following table. Now, let's look at the experiment that was carried on E. The test is the test, the observation, and the inference. And here in the first column here, in the first row here, under the test, we have E plus water, meaning that they add water to E, to sample E, and they stirred, then filtered. So what did the observer observed, or what did the analyst observed? Now, partly soluble. Now, when something is partly soluble, that is, some portion of this sample dissolve in water, while the rest are insoluble. For instance, now when you have a substance that are insoluble, below the something like this. In a test tube, we have the substance. Let me use a green marker because we have a substance that are insoluble in water. You will see, if you see the water the substance that are insoluble in water, it will stay below it will stay below they will stay at the bottom of this solvent use. But when something is partially or partly, if they use partially or partly soluble in water, it means that some amount of the substance dissolve in water to form a transparent substance. When something dissolves, it means it forms a transparent substance. You can see through it. It doesn't necessarily have to become white or have to be white in color, but you can see through it. It can be light blue, it can be light green. So these are transparent substances. When something is insoluble, it forms a residue. It is opaque. You can't see through it. So that's the difference between soluble and insoluble. I think that's the difference between soluble and insoluble. If something is soluble, it means it dissolves in a particular solvent to form a transparent liquid. One insoluble are substance that does not dissolve in water and they are opaque. That is, you can't see through them. So when you have a partly soluble, it means that it will contain two layers. It will contain two layers. Let me just say it contains two portions of solution. There is going to be two kind of layers that is going on. That is the filtrate and the residue. The one that dissolve to form a colorless, to form a transparent liquid or colorless, or to form a transparent solution, and the one that is remaining undissolved, which is called residue. And let's do it together. Partly soluble, colorless filtrate, bluish green. Partly soluble, colorless filtrate, bluish green. Now, if that be the case, let's use red marker to draw our test tube. Now, so this is our test tube now. And C and E is a sample salt. And when we dissolve it in water, we have bluish, blue, and green. Bluish and green So bluish and green residue, and the other one is filtrate. Colorless, that is filtrate. They say colorless what? Filtrate. That is, the filtrate has no what? Has no color. The filtrate has no colorless what? Filtrate. It's a colorless. It's a colorless what? Filtrate. Colorless what? Colorless filtrate. Colorless filtrate. So now you can see that, just to understand what we are trying to say here, this is a bluish what? This is a bluish green residue. So we have what? We have the residue here. We have the residue here. And we have the filtrate on top. So what are you going to write in your what? In your reference? You have to what? Say colorless what? Filtrate, bluish what? Residue. Bluish residue. Now, what you are going to say here is that, what are you going to write in what? Now, the presence of bluish what? Green residue is likely from, there are two sorts. There are what? There are some sorts that has color. There are some sorts that has what? That has color, and when they possess what? When they possess what color, they are one of the way you what? You indicate those sorts is by their color. For example, now copper sulfate is what? Is blue in color. Any copper salt is blue in color, especially when it is what? Although there are some that are white in color, which has undergone so some water of what? Dehydration, so making it white, and I just what? Copper sulfate. So, but most especially copper, even anhydrous what? Copper sulfate, when you add water to it, it turns to what? It turns to green. So copper sulfate, it turns to blue. Copper sulfate, what am I trying to say now? There are some salts that are colorful in nature. They have a specific color, and one of the salts that has a specific color is what? Is copper sulfate. It has blue color, and this is because of the what? Copper is a transition element. Copper is a transition element, and because it's a transition element, it possesses variable oscillation state, which make it to be colorful. So when you have bluish now, it's either we have copper or we have iron. Now, iron 2+ is what? Is green. Iron 2+ is green. While copper 2+ is what? Is blue. So there is tendency that this bluish green contains what? Is that copper 2+ or iron 2+? Because iron 3+ is brown, something dirty brown or something like that is brown. So iron 2+ is green in what? In color. So now you can easily write here Cu2+ or Fe2+ present. Why? Because this gives us bluish what? Green residue. And colorless filtrate. When I talk about colorless filtrate, you can just write anything can be there. You can just write what they say it's partly or soluble. It's partly, so you can say E is a mixture of what? E is a mixture of soluble and insoluble what? Of soluble and insoluble. Don't use hypersand, just an insoluble salts. A mixture of soluble and insoluble salt. Now that is that. So that Cu2+ Fe2+ present because of the blue and the green residue that we obtain. Now when residue plus heat, when the residue is being heated, or when you put the residue on fire, what do we observe? He said the observer or the analyst observe evolution of colorless gas that turns lime water milky. Evolution of colorless gas which turn lime water milky. Now evolution of a gas when they apply heat to the residue. So it means that this residue is being separated from what? From this residue that is formed below the solution, or at the bottom of the solution, is what is being filtered. It's being filtered from the filtrate, and that residue is now, we now apply it to that residue, and we are told that there is what? There's an evolution of what? There is an evolution of gases, and this gas turn lime water milky, and the only gas that has what? That has the ability to turn lime water milky is CO2. The CO2, it's a confirmatory test of what? CO2. It's one of the confirmatory tests of, so CO2, which is carbon dioxide or carbon 4 oxide, is what? It has the ability to turn lime water milky. So what am I trying to say? So this is showing that what? CO2 from CO3 CO3 2 minus present. Now, so then you can say CO2 confirmed, CO2 present, CO2 present, definitely there's CO2 present. Now, residue plus HNO3. Now we now have what? Residue again. You bring a portion of what? The residue again. You have HNO3. That is, you add an acid to it, a mineral acid. And the mineral acid is HNO3. Vigorously effervescence. Also, there is an effervescence. That is, there is a release of some what? Gases also. So effervescence occur. Something effervescence, like a kind of bubble. A kind of bubble occurs. So now, which turns what? The effervescence or the vigorous effervescence of gases, bubble of gases, turns lime water milky. Now, this is a confirmatory test of CO2 because we are using another reagent here, which is HNO3, and because we use HNO3 now, and there is a kind of effervescence, a kind of bubble in the test tube, and which also turns lime water milky. It means that CO2 gas is confirmed. CO2 gas confirmed. So is confirmed. So CO2 gas is a confirmatory test of what? Of CO2. Now let's go to the portion of the filtrate we are done with. So the portion I haven't done with what? I haven't done with what? A Roman figure 3. Then the Roman figure 4 is a portion of the resulting solution from A Roman figure 3 plus what? NH3 aqueous ammonia. So in drops and then in excess. So we are told that what? The result solution from what? A Roman figure 3 and aqueous ammonia is added to that what? Solution. And what do we observe? What does the analyst observe? Now, blue gelatinous precipitate 4. And when you say blue gelatinous precipitate, what is the kind of cations or anion that has these what properties in blue gelatinous? And one of the cations that has these what properties is what? Is copper. Copper has the tendency to form what? Blue gelatinous precipitate when dissolved in aqueous ammonia and sodium what? Hydroxide. So when you dissolve, when you add sodium, aqueous sodium hydroxide or aqueous ammonium hydroxide to a what? To a copper solution, it forms blue gelatinous precipitate. So we said copper is what? Present here. So do not go to remember. They say copper 2 is present, but we can't say it is confirmed. So it is present. Copper 2 is present. Now remember we are using aqueous what? Ammonia. Now when you dissolved any copper solution in aqueous ammonia in drops, it gives what? Blue gelatinous precipitate. But when you keep on adding it in excess, that is when you have that so aqueous ammonia to the what? To the copper solution in excess, we are going to have deep blue, meaning that the copper solution will be what? Will dissolved. It dissolve in what? In aqueous of ammonia to form a deep blue. Even though as it form a deep blue, it what? It is transparent. As it form deep blue, the color what? Transparent. So what I'm trying to say is that when you add aqueous ammonia to the solution obtained from above, which it will form what? It will form blue precipitate, and then when you add excess what? Aqueous ammonium to it, the blue precipitate what? Dissolve to form a deep blue solution. So we are going to have a deep blue solution, and this is a confirmatory test of what? Of copper what? Of copper ion. Now, so what do you observe here? Blue precipitate, blue, let me write it very. Blue precipitate dissolved to form a deep blue solution. In SS aqueous ammonia. In aqueous ammonia. So what do you write in the reference? C2 plus confirmed. C2 plus confirmed. So that is a confirmatory test for what? For copper 2 ion. Now, I haven't done the what? The A part of question number 2. Now let's move to the what? To the B part, and this is the where the filtrate of the, and this is where the filtrate of what? Of sample E is being what? Analyzed. Okay. Welcome back. And here is what? Here is the what? Okay. Let's go to the American. We are getting it. Now. So I haven't done the what? The A aspect of the what? Of question number 2. Now let's move to the what? The B aspect. And here we have the test what? Under the test, we have portion of the filtrate plus aqueous sodium hydroxide in drops and then in excess. Then the observation was white gelatinous precipitate formed, precipitate soluble. Then what will be our inference in the what? In what should be our inference? Now let's go back to the what? The questions. Now consider the filtrate of the E. Now when you have the portion of filtrate plus the sodium hydroxide, that is aqueous sodium hydroxide in drops, and you have a white gelatinous precipitate. Whenever you have a white gelatinous precipitate, there is tendency to have 2 ions in that what? In that sample or in that filtrate that we are talking about. And one of the what? Ion that might be present is the zinc 2 ion and the aluminium what? 2 ion, because they are the ions that form a white gelatinous, a white oily substances on the what? They form a white oily substances with the what? With the gas. You can see it from the test that these are white substances which have an element of oily substance in it. So that is why the tendency of having what? Zinc 2 plus and aluminum 2 plus is very high. So we have zinc 2 plus because of the white gelatinous precipitate, and aluminium 3 plus. So it's likely to be present. Now precipitate soluble. Now both have the tendency to what? To dissolve in what? In sodium hydroxide. Both have the tendency to dissolve in sodium hydroxide. So we write what? They are both confirmed. C2 plus Al3 plus, both what? Present. So we don't need to repeat. So they are both what? Present. So that is that. So we could say that is either the zinc 2 plus or aluminum 2 plus are present in what? In the what? In the filtrate. So because they form white gelatinous precipitate with what? Sodium hydroxide in drops and what? In essence. Now portion of the filtrate plus ammonia, aqueous ammonia in drops, then in excess. Now, portion of the filtrate of aqueous ammonia, portion of the filtrate plus what? Aqueous ammonia in drops, then in what? In excess. What do we observe? What are we going to observe under that? Under the light of what? Portion of the filtrate plus what? Aqueous ammonia in drops, then in what? In excess. What we are going to observe is that there is going to be what? Also white gelatinous what? It's going to be white gelatinous precipitate. PPT. I'm going to have what? White gelatinous precipitate. So the same thing that is formed under what? Under sodium, aqueous sodium hydroxide in drops will also be formed in what? In ammonia what? Aqueous ammonia or sodium ammonia solution. So we now have what? White gelatinous precipitate. So what are the tendencies? So we have zinc 2 plus also. Now we have aluminium what? 3 plus present. So they also have what? We have white gelatinous precipitate and zinc 2 plus and aluminium 3 plus present, because they both also have white gelatinous precipitate in aqueous ammonia. But in excess, the white PPT, the white gelatinous PPT is insoluble. Now, when you have the white gelatinous precipitate insoluble, white gelatinous precipitate insoluble, that is saying that that filtrate is containing what? Is a confirmatory test that that filtrate is containing what? Zinc 2 plus, because zinc is always zinc 2 plus among the two ions that will speculate that is insoluble in excess aqueous ammonia. Do we get that? So when we discover that the filtrate is insoluble in excess aqueous ammonia, we can say that it is of a truth that zinc 2 plus is present in the filtrate, is confirmed in the filtrate, not aluminium 3 plus. So that's a confirmatory test for what? Zinc 2 plus. Now, that's the confirmation. So the white gelatinous precipitate insoluble. Why? The white gelatinous precipitate of zinc 2 plus and aluminium 3 plus we are both soluble in what? In sodium aqueous, sodium hydroxide, So this don't miss it all. So now, portion of the filtrate of barium nitrate plus dash white precipitate. Now, whenever you have portion of the filtrate with barium nitrate or barium salt, whichever the barium salt you are adding, whether it's barium nitrate, whether it's barium chloride, when you add a filtrate to a barium chloride or barium nitrate, and there is a tendency that you have a white precipitate. And when the white precipitate is observed, when the white precipitate is observed, what are the tendencies? What are the ions that you are likely to find there? One of the ions that you are likely to find there is SO3 2 minus, SO4 2 minus. These are the anions that you can find there. So we have what? CO3 2 minus, S2 minus, present. They are all present. And tendency of what? They are tendency to find, not that they are all present, but they are tendency to find SO2 minus, SO4 2 minus, CO3 2 minus, S2 minus. These are the likely what anions that you can find when you add barium sulfate to filtrate. So when you add barium sulfate to the portion of the filtrate and you get white PPT or white precipitate, SO3 minus, SO4 2 minus, SO2 2 minus, S2 minus, that is the sulfate ion, carbonic ion, and sulfite ion are likely to be present. Now, but when you now add dash and the precipitate what remains, that is the precipitate persists. It does not dissolve, it persists. So what are the things that is likely to be found? The precipitate what remain. So now in this case now, an insoluble in what? In excess. In this case now, the only anion that has that tendency not to dissolve in acid, is what? Is SO4 to minus the sulfate ion. So this is a confirmatory test of sulfate ion. So sulfate ion confirmed. Now, when I say insoluble in acid, so you can use any of the acid here. You can use diluted HNO3, HNO3. You can use dilute what? ACl. You can use any dilute what? Acid. Dilute what? Minerals what? Acid. HNO3. Can put mineral, dilute mineral what? Acid. It can be, don't write minerals acid there. So just write dilute HNO3 or dilute ACl. Can be in this place. Dilute HNO3 or dilute ACl. So now this is the end of the class. Please and please remember to subscribe to this YouTube channel. And if you have any questions, drop your comment below, and we will be willing to attend to your question. And before we go, now you can see that from our experiments and from what we are being given, we could see that there is tendency to have a E. There's tendency, and the what we can actually conclude that E is a mixture. A is a mixture of what? Of copper carbonate. Copper carbonate. Because we have copper in iron here, we have what? We have CO2 here from CO3. So there's a tendency we have mixture of copper carbonate, which is what? Which can be blue, or this can be what? This can be green in color, which can be green in color. So copper carbonate is green in color, and what? And zinc what? Zinc sulfate. So these are the mixture of